Hello guys, so sorry for the late posting again. I just had to do something. Today, or not today, now, I'll go deeper into the equations. First, the most basic equation we have is work is equal to force times distance. This is the case if we have the force, all right, is the same direction as D, okay, and the angle made with x axis is 0. For example, this is our plot, okay, and this in blue is our force. The angle made with the x-axis is 0, and the force is the same direction as the distance. Alright? So for now, this is the first case. The second case we have is minus F times D. This is when the force and distance are in opposing directions, so oppositely, okay, and angle made with x-axis is equal to 0. So for example, take another example. We have this is the force, but the direction is backwards. Okay, we have the force and direction are opposing, and the angle made with the x-axis, which is this, is 0. So we're going to use negative F times D. Another thing, if it's positive F times D, then it is motive. If it's negative F times D, it is then it is resistive. Now, that was the first case. The second case is if we have force times distance and there is an angle made with the x-axis. For example, we have a right triangle, okay, 30, and the force is going upwards. For example, or let me draw it better. We have a force going upwards like this. This is our base. This is 30 degrees. Okay, so here, let's say the force and direction, okay, are same. Sorry, the force and the distance are the same direction. All right, look, the force and the distance are in the same direction. That means they are motive. If it is motive, then it's positive F times the distance, okay, multiplied by cosine of the angle 30, because 30 is made with the x-axis. Now, if we're gonna do another case, for example, we're gonna do negative F. So F and D are in opposite directions, okay. We're gonna draw the same graph, but just say that F and D are in opposite directions. What will happen? The force will become negative force, okay, times distance, times, again, the cosine of 30. So this is work is equal to force times distance times cosine angle made with x-axis. Now, I will break down work equals force times distance. If you remember, Newton's law is that F is equal to ma. So let's substitute F by ma. Now we're gonna get W is equal to W is equal to m times a times d. We know that the acceleration is what? It's v final minus v initial over time. Alright, so acceleration is equal to v final minus v initial over time. And we know that the distance is equal to the v final plus the v initial over 2. This is 2. Let me fix it. Over 2 multiplied by the time. These are rules you should have known from before, from last year. Okay? Now, if we're gonna substitute acceleration with this, we're gonna get W is equal to mass times the acceleration, which is v final minus v initial over time, times the distance, which is v final plus v initial over 2 times the time. If you're gonna multiply them all, it's gonna be mass times v final minus v initial times v final plus v initial, okay, times the time over time times the 2. Now you're gonna remove the time and the time, and then you're gonna have m, or 1 over 2m, or m over 2, however you like it, okay, times v final squared minus v initial squared. Now you have to be really good in math to get this rule. This is what, by logic, we got this rule. Alright? This, we broke it down, we substituted, and we got this rule. Or, simply, very simply, you can say that work is equal to the change in kinetic energy. Alright? Now, what's change in kinetic energy? It's kinetic energy final minus kinetic energy initial. What is the rule of kinetic energy? Kinetic energy is equal to 1 over 2 mass times velocity squared. So if we're gonna do the difference, it's gonna be Ke final minus Ke initial. Alright? So it's gonna be then 1 over 2 mass times velocity final squared minus 1 over 2m times velocity initial squared. Okay? Then if you're gonna simplify it, it's gonna be 1 over 2 mass times v final squared minus v initial squared. So you can either do the first way, which is really long, really complex, but it's really logical, or you can do this way, which is memorization, that work is equal to delta Ke. This is called what? The work energy theorem. Alright? That was for this one. Now we're gonna do power. Power is equal to work over time. No matter what the work is, you're gonna use work. Okay? You get the work, and you're gonna put it in joules over the time in seconds, and then you're gonna get your power, which is in watts. Okay? Power is very easy, one of the easiest ones. Now here we come to mechanical energy. Mechanical energy, if you remember previously, it is kinetic energy. So mechanical energy is equal to kinetic energy plus potential energy. In this chapter, the only potential energy we're studying is gravitational potential energy. So logically, we're going to replace the potential energy by gravitational potential energy. So now we get mechanical energy is equal to kinetic energy plus gravitational potential energy. Then substitute by their equations. What's the kinetic energy equation? It's 1 over 2 mv squared. And then, what's the equation of gravitational potential energy? I didn't reach it yet, but I will explain it down. Okay? But know that for now, the rule of gravitational potential energy is mgh. Okay? Now, there is something called the law of conservation of mechanical energy. It says that the initial mechanical energy is equal to the final mechanical energy. We said previously, mechanical energy is kinetic energy plus gravitational potential energy. So that means kinetic energy initial plus gravitational potential energy initial is equal to kinetic energy final plus gravitational potential energy final. Now let me zoom in here. I wrote this equation into different colors. Let's understand why. First thing, we have, for the Ke initial, we have 1 over 2v initial squared, okay? Plus, for the GPE initial, we have plus or minus mgh initial, alright? So, we have gravitational potential energy can be either positive or minus, okay? And then we have mass times the gravity times the initial height. This is initial. This is me initial. It's equal to me final, which is Ke final, which is 1 over 2 m times velocity final squared, plus the plus or minus m times g times the h final. Now look at the ones in red. You can cancel the 1 over 2 with the 1 over 2. And you can cancel the plus and minus m with the plus and minus m. So we're going to be left with v initial squared plus g times h initial is equal to v final squared plus g times h final. So far, this is the basic equation we need to know. For mechanical energy initial is equal to mechanical energy final. So we finished mechanical energy. Now let's go to the gravitational potential energy and the GPE, which is the gravitational potential energy, which is GPE and the gravity. So whenever we are plotting the GPE, okay, we always have to have something called a reference level in which the GPE is 0. From this reference level, if we go up from this reference level, then we are positive GPE. We're going to have more gravitational potential energy. What is, by the way, gravitational potential energy? It is the stored energy from being above reference level. So for example, let's say the reference level is my floor. If I stand on my bed, I will have a higher gravitational potential energy than when I stand on my floor. And if I go to my neighbors who are under me, then I will have a less gravitational potential energy because I'm going down still more. Okay, so stored energy from being above reference level is the gravitational potential energy. And why do you need to store gravitational potential energy? Imagine your floor disappears. What will happen? You will fall. When you fall, you're doing what? You're doing kinetic energy. So for this kinetic energy to happen, you should have energy stored from before. This is why we store GPE, or gravitational potential energy. Now, if we go higher, the GPE increases. If we go lower, depending on the reference level, then the GPE decreases. Okay? Now, this means if an object is lifted, or rises, or goes up, or anything along these terms, it's positive GPE. However, if anything goes down, is dropped, what's the opposite? Is falling, okay? Then it is negative. That is for GPE. Remember, the equation for GPE is m times g times h. Now, we're going to discuss gravity, then we are going to discuss why I wrote gravity 2 dots minus GPE and GPE 2 dots minus gravity. So, gravity, okay, is the work done by the earth, the work of pulling the earth towards itself. So, if something is falling towards the earth, of course it's going to have more gravity, so it's going to be positive. If something is going away from the earth, it's going to have less gravity, so it's going to be negative. So, I am, let's say, on the earth, okay? My gravity is then balanced because I am on the earth. If I go, for example, above 2 floors in a building, then my gravity is going to be less because I'm going above the surface of gravity. So the gravity will not be functioning properly. And because I'm going up, it's going to be negative. But however, if I am, for example, on the 5th floor in a building, and then I go down to the 4th, for example, I go down 1 floor, my gravity will be stronger. So Earth is pulling more because I went down. So that's for the gravity. That means if something is falling, doesn't fit here. If something is falling, dropped, goes down, in the case of gravity, it is positive. I can't circle it, but it is negative. There's a barrier. I don't know. It's not visible. Okay, but it is negative only if it's lifted or it rises, or it goes up. Now, if you noticed, the GPE is the total opposite of the gravity. They are totally opposite. What does this mean? If they are totally opposite, then the GPE is negative of gravity, because negative means opposite. And gravity is negative GPE, because negative means opposite. And that's it for the AMS tomorrow. These are the equations and what's mainly needed to be known. Don't forget, I'll write here, do not forget to write the given. It will help you so much in solving. It's very, very efficient. So thank you guys for watching.